So hey everybody, I'm Hannah. I'm one of the LAs here, and I just want to do a quick walkthrough of activity number 2. I just talked to you guys a little bit ago. The first video, we were waiting for the Wi-Fi to figure this one out, but this is just a general recap. I want to show you guys kind of what you should be doing, what you should be looking for. This one will not be as in-depth as the last one, just because I know that my class especially, and I talked to some other LAs, got through this activity more. But I also still wanted to send out a recap video because I know you guys have been super overwhelmed with everything that's going on, but we're starting to get a hang of things. So I want to remind you guys, make sure you're watching the lectures first before you're doing anything else. Watch the lecture, then start working on the smart book and keep going from there. And then you'll end the week with our LA activity, which is kind of gonna really be where you start to use all that information. These are gonna be test-like questions. And so I just want to do a little recap. Once again, slightly weird setup. I'm talking to a camera, I have my screen I'm writing on, and then I have my other screen. So if my eyes aren't always tracking, just hold with me. So first thing we're gonna do is write out the Centra dogma of molecular biology. So I'm just gonna kind of walk you through my thought process and then explain everything going on. So first thing I think of when I think of molecular biology is DNA. We are going to start with our DNA. That DNA then transforms, as we all know, into RNA. RNA finally makes protein. Now we need to talk about the processes that do that. First, DNA has to replicate itself. Before it can do anything, it replicates. From there, to go to RNA, we have transcription. So transcription means to write. We are writing the new code, we are moving it forward kind of deal. Then lastly, we have RNA to protein, which is where we have translation. Think about how you are physically, you're rewriting, you're translating into that new language of the protein. So for my class, I did little drawings. This is my polypeptide chain going on. For RNA, we have our single strand of DNA or RNA, and then our DNA, we have those helixes. Okay, this next part is just the table. Guys, you should be able to go through and name what each of these things are. I'm not going to spend the time to do that. That's something that you can look back into your notes and something that I know you guys are all capable of. But we are going to talk through this part. So the first question is, leaving out the specific sequence, draw and identify the 3 different shapes. So I already drew my 3 shapes. So let's talk about this arrow first. Your arrow is that starting point. And before you can even touch any part of the gene, you need your promoter. So that promoter is what kind of kickstarts everything. Our rectangles are those exons and introns, which is the meat of what we're working on. That's the actual gene we want. And then if you promote something, you got to stop it or terminate it, which is where you get, oh, I already spelled that word wrong, where you get that terminator. Sorry guys, I'm not great at spelling. I'm good at science. Next, what is the name of the first process that will take gene one step closer to being a protein? Going back to our central dogma, that first process is transcription. We're making it into RNA. So we need an RNA polymerase. This is the workhorse. So I already drew it out, but I just kind of want to talk through it. So we have, I'll use a highlighter to talk through it. We have our DNA strand. You can follow the 3 versus the 5. The 3 is what's getting split and that RNA is being built off of, which happens right here. This is done through those ribonucleic triphosphate that are moving through the tunnel to the active site and then being spit out as this RNA. So you can see the new RNA is being formed here. Some things you want to make sure you have or note: the closed jaw configuration, where our active site is, where our tunnel is, this exit channel, and that we are using RNA polymerase. Next is, what is actually the sequence? What are we working with? So I just went out and rewrote. So pause this if you haven't done this yet and write out that original rectangle. Make sure you're labeling exons versus introns versus exons. So introns are actually spliced out. So the first thing I did was I just spliced it out and put exon 1 and exon 2 next to each other. Make sure you're noting where your 5 and 3s are. Pause if you haven't done that. Next, since we're going from DNA to RNA, we drop all of our T's and we pick up uracil. So next thing I did was I just went through and I took out all my T's and flip them to use. Then we get to the actual processing piece, which is where you add your 5' cap and your 3' poly A tail. That being said, you can just write 5 cap. You can either write that 3 poly tail like Professor Harrison did, or I just wrote out a bunch of A's. It is totally your choice. Next, it says draw up the process that turns nucleic acids into polypeptides. So this is one I really want to talk through with you guys. I started talking about it with my small group or my class, but this is where a lot of confusion is. So first thing, we are working with our ribosome. We have the large subunit up here and our small subunit. So then our tRNA is over here. I want to break it down for you guys. You have the amino acid attached to this anticodon. This anticodon is going to slide in to the A site, A landing site. This anticodon will match with this codon. As you can see, our G's go with our C's. Those are kind of arbitrary right now. You guys will not be forced to know. And then it will slide into the P site. The P site is where this amino acid right here is going to connect through a peptide bond to the other amino acids. So it breaks off from that tRNA part and the amino acid stays. What's left, that anticodon and the connection, will move into E, and E for eject, exit, whatever you choose, and that will head on out. So to review, we have our mRNA, our tRNA, our anticodon right here, our codon, our large and small subunits, our amino acids that are formed together in peptide bonds while breaking hydrogen bonds. So lastly, what is the sequence of amino acids in process 5? So I just wrote these out, and as you can see, I clumped them in groups of 3 because that didn't finish because there wasn't any more, but you get amino acids in groups of 3. So then you need to find your start codon first, which is always going to be an AUG. That is something you should just always know. So how you read this is A, then we find our U column. So A, U, then we go down to G. So we have MET. Next we have, let me change my colors, a G, U, G, which is Val. Then we have our UUC. So UUC. And then our stop, as you can see, UGA. So this is our final sequence. I know that there is more to this worksheet that has discussion questions. I know my class got through some of them, not all of them, but if you guys have questions on those discussion questions, you have 2 options. You can bring your questions to class on Monday, ask your professors, they're equipped to answer them. That's going to start to be kind of our normal flow, is pushing what we don't finish into Mondays, because I know that you guys have questions and we want to answer those questions, but I also don't want to just always give you guys the answer, which I know can be frustrating. Or 2, you can Slack me. I will help you through. You can Slack your RA. They are also equipped to help you through. So good luck, guys. Make sure you're watching the lecture videos. Make sure you're finishing your Friday activities, your smart book. Check out the Slack general channel to see all the things that Harrison caught you guys up on today. Good luck, guys.